Hello, we are Team B, and today we are going to present the project called Pittsburgh Flight Delays Prediction. Our goal is to predict the departure delays in the flight that take off or land at the Pittsburgh Airport. We accomplish this goal through four activities. First, we perform an exploratory analysis to identify patterns and understand the data distribution. Second, we merge historical flight data with weather information. Then, we identify the most relevant variables to predict the flight delays. And finally, we use different machine learning models to make the prediction. But first, why this topic is relevant for public policy. All USA airports except one are operated and owned by public entities. Also, they contribute with 7% of the GDP and more than 6% of the total workforce. However, flight delays cost $32.9 billion to the US economy, and half of them are borne by the passengers. So, a model that predicts the flight delays can be used by selling flight companies and passengers to make better informed decisions. For this project, we used two datasets. First, a scale dataset of the USA domestic flights in 2015, or nearly 5.8 million flights. Second, we built a dataset of hourly weather-related variables for all the USA airports based on the NOAA data. This dataset has 2.8 million observations. Then, we merged these two datasets based on the scheduled departure time and origin of airport, as well as based on the scheduled arrival and destination airport. Once we filtered the observation for the Pittsburgh Airport, we remain with 52,500 observations.
We created two models. The model one is the same day prediction. Its objective is to help customers to make or change decisions regarding immediate events. And the second model is the 2 weeks in advance prediction, which has the objective to help customers to predict before buying their tickets. The difference in the models is that in the second model we didn't add precise weather data. Instead, we put a proxy for weather forecast. We tried the different classification methods, as we have a classification problem with two classes, delay or not delay. The performance metrics show us, especially in the holdout test dataset, that the support vector machine and random forest dominate all other models. We can see in the table below that they have the highest accuracy, F1 score, and AUC in both the Model 1 and the Model 2. Also, looking at the ROC curves, we can see that both the supervector machine and random forest dominate all other models in all other methods in both the same day model and the 2 weeks in advance model along all the false positive rate range. The feature importance in the random forest, we can see that the same day model, the most relevant features are the scheduled departure and the previous delay. And in the 2 weeks in advance model, we can see that the day and day of the week are the most relevant or important features.
So we developed an example to see how the model can be applied. So we imagine a businessman that he's booking his flight on a Saturday, May 26th, and he's planning to fly on June 9, that is also a Saturday, at 8:45 a.m. He's planning to fly from Orlando to Pittsburgh by American Eagle Airlines, and given these variables and the weather forecasts, the probability of delay is of 88%. So given this information, the businessman can now schedule this meeting and he can also decide to not buy this flight. So in conclusion, building a predictive model of the flight delay can avoid economic losses and allow users to make better informed decisions. Also, companies that sell flight tickets in internet can add this new feature, flight delay, and this could be very useful for the customers to decide to buy their ticket or not, or plan their meetings or activities. Thank you very much.